Hello and welcome back to Digital Replay. Today we're continuing in Unit 1, the introduction. We're now on pages 14 through 21, and we're covering measurement, and this is a two-parter, so part 1 of measurement. In the United States, we use a measurement system called the U.S. measurement system. And in this system, there's some pretty hard to remember conversions. For example, how many inches are in a foot? Well, 12. But do you know how many chains are in a furlong? Or how many furlongs are in a mile? The U.S. measurement system leaves a lot to be desired as far as memorization is concerned. And a lot of the world uses something called the metric system. And the metric system uses kilometers and kilograms and these things, liters, that are actually broken up into base 10 units. So it's a lot easier to remember if you learn how to use the conversion factors, which is what I'm kind of going to talk about today after we talk about what the metric system is. Now, in science, we don't use the metric system. We use the International System of Measurements, or SI. And the SI system is the worldwide language of scientific measurement. It helps if scientists all speak the same language when we're talking about distances and weights and masses and energy and time. If we're all using the same language, then it helps. We don't have to do any conversion. So let's talk about the SI base units here. The SI base units. What's the base unit for mass? Which is kind of like weight, but without the gravity or force component. Mass is measured in grams. Mass is measured in grams. And grams is designated by a lowercase g. Length is measured in meters. That's the base unit. Meters, which is designated by a lowercase m. Temperature for the SI system, not for a metric system, but for the SI system, is designated by a capital K, and that's because we measure in Kelvin. Now, in the metric system, we measure in degrees Celsius. We're not measuring in degrees Celsius in this. We're measuring in Kelvin in the SI system. And time we measure in seconds, which is designated by a lowercase s. There are also derived units in the metric system, which means that they come from the base units. And you'll see what I mean in a second. We measure area by square meters. It's a derived unit because we get it by multiplying two things together, having two units multiplied together. Volume we measure by the liter, which is a derived unit, and this is a little bit complex, but I'll give you the rundown. 1 milliliter equals 1 cubic centimeter. Okay, so this is where the derivation comes from. This is the, obviously, when we're measuring area, we go meters times meters. And if we were to measure volume in the same way, we'd go meters times meters times meters, right? So then we have this liquid volume way of doing a measurement, which is liters. So 1 milliliter equals cubic centimeters. That's why it's a derived unit. Now, density. Density would be mass per volume ratio. So it's grams per cubic meter. Grams per cubic meter. And then energy is another derived unit. And we designate it with a capital J, which is joules. And joules stands for the kilograms. I'm going to write this out here. You don't have to have this memorized. Kilogram meter squared per second squared. And we get to work with that later on when we're working with carts. But this is just an introduction, right? I don't need to get into it too far. It's time to play Choose Your Unit! The unconventional contest where we find natural things around the house and we decide what unit we should use to measure them. Whoa, how much ink did I use on that test? Oh, dude, how heavy is this thing? It's like heavy. OMG, how much longer until class is over? How far do you think I can stretch my gum? Oh no. How much did I drool? Ugh, it's so hot in here. How hot is it? Okay, I wonder how fast I can get to the cafeteria and back without the teacher noticing. I wonder how far I can throw this pen. We've now had our introduction to all of the different kinds of measurements we can take with the SI system. But let's talk about it a little bit. The meter. Meters are great when you want to measure something small like Justin Bieber. But let's say you wanted to measure something even smaller, like those hairs you bought on eBay. Make sure they really did come from Justin Biebs himself. Or maybe you want to measure something really, really big or really, really far, like the amount of distance that the Virgin Galactic spaceship has to travel in order to get the Biebs off of this planet. Well, when you want to do that, you can actually still use the same units, meter, but what we do is we put a prefix in front of it, a prefix. Now, a prefix is pre means it comes before, and fix means a figure. It's something that comes before the word. So we can actually put a prefix on meter to start measuring bigger things or smaller things. For example, here is a ruler zoomed really close. No, that is not my hand. And remember that the SI unit for length is meter. Now what we do is we take a prefix and put it in front of the word to talk about the size of that demarcation. So in the meter stick, we can have centimeters. So each of these little lines here, these lines with the numbers, each of these little lines with the numbers, this is 1 centimeter. The distance between here and here is 1 centimeter. There are 100 of these little line segments in 1 meter. In the decimeter, you see this is a decimeter. The decimeter equals 10 centimeters. There are 10 decimeters in 1 meter. I think it's time for some examples. And the examples I want to use are this little action man and the width of a pencil lead. Okay, so let's measure the height of the action man. He's 0.095 meters tall. And the width of the pencil lead is actually 0.0007 meters. That's very, very small. It's a lot of zeros, and it's a lot of writing. So if we converted this somehow, we could make it easier to write. And that's what I'm going to show you really quick here. We use something called conversion factors. For every meter, there are 100 centimeters, which means that a centimeter is 1/100th of a meter. We can also write this in base 10, which is 10 to the minus 2. Now another delineation on the ruler you can see are these little itty bitty lines. Each of these little itty bitty lines is 1 millimeter, or 1/1000th of a meter. That's 10 to the minus 3. These are called conversion factors. Now we have our conversion factors. Let's convert the height of Action Man into something smaller, let's say centimeters. First, we write down what we know, 0.095 meters, or the height of Action Man. Draw our conversion table, and then we write centimeters on the top because that's what we want to end up with. Centimeters is the same as writing 10 to the minus 2 meters. So now all we have to do is divide 0.095 meters by 10 to the minus 2 to get the number of centimeters that is Action Man's height. You may have learned that this is just like moving the decimal place every time you divide or multiply by a power of 10. So all I'm doing here is trying to show you how to do this in one step. So plug it through your calculator, and what you get is 9.5 centimeters. We can do the same conversion for the pencil lead width. So first we write down what we know, 0.007 meters. Then we draw our conversion table, and we know that milli means 10 to the minus 3. We want to end up with millimeters, so we put 10 to the minus 3 on the bottom. Then we just divide. We plug it into our calculator, and voila! 0.007 meters equals 0.7 millimeters. Now we just worked with centi and millimeters, and we learned that centi is 1/100th, or 10 to the minus 2 meters, and we learned that milli is 1/1000th, or 10 to the minus 3 meters. Now it turns out that there are other prefixes that have different base 10s associated with them, and it also turns out that it doesn't matter if you use meters or liters, grams or whatever, every single time these prefixes work. So 1,000 grams is called a kilogram. Hopefully that wasn't so confusing. The big takeaway that I want you to get is that writing the prefix, the little letter that comes in front of the base unit, writing the prefix is the same as multiplying or dividing by that base 10. Okay, so if you memorize all of your prefixes and your base 10 units, you're going to be able to convert between anything, anytime, anywhere. When I write the letter C here at the end, it's the same as writing times 10 to the negative 2. When I write the letter C here, it's the same thing as writing 10 to the negative 2 times 10 to the negative 2. The first time you see a table like this, you might get overwhelmed. Just know that there are more prefixes than what we are learning. Be aware that we will be using a lot of these in this class. The ones I want you to have pretty well down are the ones right here closest to the base unit. Kilo, hecto, deca are the bigger ones, and deci, centi, milli are the smaller ones. So these are the ones I kind of want you to know. Now we will also be working in nano and pico when we start doing time. So keep these ones in mind too, but the most important are the ones highlighted here in orange. Wow, that's a lot of information. The SI units are the universal language of scientific measurement. Prefixes make conversions a lot easier, but only if you learn them. So spend some time today to learn your prefixes. This has been your digital replay for Unit 1, the introduction, part 1 of measurement, and we'll see you next time.